Okay, welcome everybody. We are right about now taking a look at sketching a new type of function that you have not learned how to graph yet, all right? But what we're going to do is we're going to take a lot of the things that we've already have learned in this unit, mapping notations, plugging x and y points into the mapping notation to get a new set of x and y points. That's something you're going to see a lot in 12A and 12B, and maybe even calculus as well. So at the end of these 12A and 12B classes, you're going to notice that you have about 8 or 9 different types of functions that you're going to learn how to graph. And this is the first one, which is the square root of x. So with all these functions, you have a basic table of values. Then you get a mapping notation, and you plug those points in, and you get a new table of values, which you graph. Okay, so that's the routine for all of these functions. Let's set up a table of values for this basic function on the very left, which is the most basic square root function that you're going to compare all of your other graphs to. So we want to take some values of x, get the square root of those numbers to get our y value. So just a reminder that you cannot get the square root of a negative number. And the reason behind that is for example, if you do square root of 9, that's a 3. And the reason why is because 3 times 3 is equal to 9. Okay, if you have a negative number in the square root, that's not going to work. The square root of negative 4 is not negative 2, because negative 2 times negative 2 doesn't give you a negative 4, it gives you a positive number. Any number that you multiply by itself, whether it's positive or negative, will wind up being a positive number, so we're only going to start at 0. You can get the square root of 0, and that is 0. 0 times 0 is 0. You can get the square root of 1. Square root of 1 is 1. Square root of, let's not use 2 or 3, because the square roots of those numbers are decimal numbers. So let's say the square root of 4 is 2, square root of 9 is 3, and we can just leave it at 4 points. You can go further if you like, but 4 points is enough for you to sketch a graph. And also what I'm going to mention right here is that you can't go any lower than 0 for x. You can't get into negative numbers. So on this part of the graph, you would have just a solid point. It won't be an arrow because it won't continue to the left of 0, but you can go further than 9, so I'll use an arrow right there. Okay, those dot and arrows aren't necessary on your table of values, but they're necessary on your graph. So what I'm going to do is I'm going to try to plot at least 3 of these points. So notice I have 0, 0, I have 1, 1, I have 4, 2, and I'm not going to fit 9, 3 on this graph, so I'll just leave it like this. And basically the shape is that it starts at 0, 0 with a solid point and then goes up and to the right, and that is your basic y is equal to root x function. So you're going to keep coming back to this basic function. Every other transformation that we graph will be based on this original function. So on the right side, okay, what we have here is we have a transformation of a square root function. So you see some numbers added on and some negatives and all that sort of thing. So what you're going to do first, for basically any time that you're asked to sketch a graph given an equation, you are going to make a mapping notation. So the things that are added here, okay, well, first of all, let's remind ourselves that the outside parts are your y values that do not change. So we're looking at 2y plus 3. The inside parts would normally have an f there when we were just doing our line segment graphs. Now we have a specific function that we're doing. It's a square root of x function. So the inside part is inside of that square root. And this is where you switch up some things. So instead of x plus 1, I have x minus 1. And then the number in front of the x is a negative 1, or just a negative. If you flip that over, get the reciprocal, it's still negative. So it's going to look something like that. And now we have our horizontal translation. It's going to move 1 unit left. It's going to move up 3 units. It's going to be stretched vertically by a factor of 2. And there's also a reflection. You can see because there's a negative in front of the x in the mapping notation, it's going to flip over the y-axis. So when we sketch our graph, it should have all of those things there. So let's take a look. Okay, let's take a look at doing a table of values. So we're going to use the original table of values on the left. We're going to take those 4x and 4y values, plug them into the mapping notation to come up with 4 new points. And what we have right here, okay, is we're going to have, if we do this, we're going to have these for x values right here. So you're going to see we plug in times by -1, then subtract 1. So you're going to get these 4 x values, and you're going to get these 4 y values right here. It's going to be 3, 5, 7, and 9. Once again, the first point is a dot, the last one is an arrow. We might not even have room to do that 4th point. So sometimes you only have room for 2 or 3 points. Okay, let's sketch this graph right here. All right, so what we're going to have looks something like this. And you can see right here that -1 and +3, we can fit that there. That is a solid dot. The -2, +5 is up next. The -5, +7 goes next. The -10, +9, we can't really get, so we'll just join these up. And remember, at the end we have an arrow, but at the beginning point, the -1, 3 point, that is a solid dot. So what we have here is a graph that looks like this. And if you look at your original function on the left compared to your new function on the right, notice what we have here, okay, is we have the reflection around the y-axis. You can see instead of going up and to the right, it's going up and to the left. So we see that much happening. We can see that the graph has moved 1 unit to the left and up 3 units as we predicted from the mapping notation. And it's also vertically stretched by a factor of 2. So we have our graph done here. Okay, we're going to add something extra to this. Okay, what we're going to do is we're going to get the domain and range. And we can do this in using the old notation with the squiggly brackets and the greater and less than symbols. Or better yet, okay, what we can do is we can use our left and right bounds, our lower and upper bounds. For x, the left bound is -infinity, because you can see through by the arrow, okay, a good reason to have the arrow there, you can see that it moves infinitely to the left. On the right bound, okay, it reaches a maximum of -1. And I use a square bracket on -1 because it actually touches the point. For -infinity, you can't actually touch infinity. All right, infinity is more of like a philosophical concept than an actual numerical value. So we would just, as a general rule, we'll just always use a round bracket around negative or positive infinity. Then we look at the y values. Okay, we want to get the lowest and highest y values. The lowest y value is 3, but then it goes up to infinity. Infinity uses a round bracket, so we have our domain and range, and we also have our graph below.